Hello, friends in geometry. I have been asked to work two problems that are on our homework that are a little bit different in that they're asking something that sort of requires multiple steps, and that is find the area of the triangle, meaning the whole big triangle, when we don't seem to have all the information we would need in order to do that. And what we're going to have to do is we're going to have to use right triangle trig to find some missing side lengths in order to get the info we need. Remember that the area of a triangle is 1/2 base times height. Okay, so I need to know the base of this whole triangle and the height. All right, when we do 1/2 base times height, the only requirement about which one is the base and which one is the height is really that they're perpendicular. They have to be perpendicular. The height has to be in altitude, which means, and I'm trying to make this a little bit better resolution, it goes from a vertex of the triangle to the opposite side or the line containing the opposite side in a way that makes it a right angle. So this is going to be my height. This whole thing is going to be my base. This 10 here is just that part right there. Okay, so what I'm going to have to do is I'm going to have to use right triangle trig, sine, cosine, tangent, to use this 10 and this 27 to find this length. Okay, that'll give me the height. That's one of the things I need. That's my h right there. And then once I have this, I can ignore that triangle completely and use this side to find this length. So that's my plan, because that way I'll be able to put this part together with this part and have the entire base and the height, and I can plug into that equation. So I'm going to think of this really first off as two different triangles. And right now I'm just going to focus on the one that's sort of on the left. It's not sort of on the left, it's really on the left. Okay, and I'm going to see if I can find that height. So according to this angle, or looking at the triangle from this angle, here's the hypotenuse, here's the adjacent. What I was doing there is the two sides of the angle are always the hypotenuse and the adjacent. So if you could tell which one's the hypotenuse, the other one is your adjacent. And here's the opposite. So in this particular problem, I am trying to find the opposite, and the side that I am using to find it is the adjacent. So I'm using opposite and adjacent, which is tangent. So tan of 27 equals opposite over adjacent. And I can multiply both sides by 10. I like to think of it as cross multiplying. That's why I put that 1 there. Equals h times 1. And as soon as I get my variable isolated, then I am ready to type in what it says on the other side in the calculator. I don't pick up the calculator until I have solved for the variable. And I get 5.0952 blah, 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 blah. Now, in terms of the height, maybe I would round to the nearest tenth, maybe the nearest hundredth. But in this particular case, I'd really like to be very accurate. So I'm going to, since I'm going to use that side to find something else as well, I'm going to go to 3 decimal places, maybe even 4. If I can, I'll use it in I'll leave that in my calculator and use it later. So let's say that h is 5.095. Okay. Because I'm not being asked what the height is. I'm being asked to use it. So now I have to use that to find this part. That's this length here. And now I'll use it on that triangle. We're no longer worried about the left triangle, just the one on the right. So I'm going to redraw that triangle. I have the 40 at the top. We know that the h is 5.095. And we're trying to find this part right here. Let's call it x. Okay, so now for the angle that we are working with, which is the 40, those are the two sides of the angle. This one is the hypotenuse, which makes this one the adjacent. And this is the opposite. So again, I'm going to use tan because I'm dealing with opposite and adjacent. So tan of 40 degrees equals opposite over, and this is 5.095, blah, 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 blah. So when I cross multiply, I'm going to get 5.095, etc., times tan 40 equals x. This is what I was talking about a second ago when I said if I can, I'm going to use it in the calculator. I haven't done anything else with that number in the calculator, so it's still there. So I'm just going to press times. And that way I'm using a much longer decimal. It's going to be more accurate than if I just used this. Times tan 40. That's what I'm doing there. So x is 4. Let's go ahead and round to the nearest tenth, and that says x is 4.3. Okay, so going back up to the top here, that means this part here is 4.3. And again, I'm really not just finding that, I'm using it, so I could have taken it to a few more decimal places. But that's okay. We'll see if we can use it from there. And then our height was that 5.095 thing. All right, so now I'm ready to find the area. So I'm going to do area equals 1/2. The base is the 10 plus the 4.3, etc. So that's 14 point all of that times the 5.095. Sorry, that got squeezed in there. So see, here's that still that same number in here. I just really like doing this, leaving it in the calculator, and then instead of using the rounded one, why not use that one? To get the whole base, I'm adding it to 10. So instead of 4.3 plus 10, I'll go ahead and use what it actually, where that 4.3 came from, plus 10. There's the base. So I'm doing that number times 5.095. Uh-oh. I have to, if I don't just press the times or whatever, the way to get it back is right here above the negative. It says A and S. So I can do second and that, and it'll come back up. And it basically uses your most recent answer. Times 1/2 is the same as 0.5, so I'm going to use 0.5. And my area is 36.36 or 36.37, something like that. Now, what did it say in terms of rounding? I don't recall. If it was asking you to round to the nearest tenth, I would get 36.4. All right, that's number 13. Let's do another one that's pretty much just like it. This one, and I will tell you that on the printed problem that my students are looking at here, it was kind of crammed up in here, the 30, and it was maybe hard to tell if the 30 was supposed to be here, where I put it, or here. How do I know it wasn't supposed to be here? Well, I don't really, because I don't know that this is a 90. So really, theoretically, it could have been there. I would just doubt it the way it's drawn. It doesn't seem like it should be. This seems like it should be something close to 90. So this seems like it would be a bigger number because these two together have to add to 90. But again, I don't really necessarily, there's not any valid reason for me to say that. Okay, because I don't know that this is 90. I don't know that it's close to 90, even if it looks like it, because we're not supposed to make assumptions based on how the figure looks. We're supposed to go with information that we are given. So I say, however, that this angle does need to be up there. Okay, so I'm going to do it that way, and let's see if I get the same answer that the key has. Maybe I won't. So again, I'm going to start over here and use this 27 to find, let's call it the height. So 22 degrees, 27 is the adjacent side, and the height is the opposite side, so I need to use tangent. So tan 22 equals h over 27. Cross multiply 27 times tan 22 equals h times 1. H is by itself, so I'm ready to type into my calculator. 27 times tan 22 is 10.9. So H is about 10.9. Let's go to 3. 10.909. All right, so now I'm going to use that number right up here to find this part. So 10.909, here's the 30, and I need this part right here. So let's call it X. And this is the opposite. This is the adjacent, so it's tan. So tan, I'm sorry, I picked up my calculator when I wasn't ready to use it. Tan of 30 is opposite over 10.909, cross multiply, and that number gets multiplied times tan of 30, and will give us X. So that number's still in my calculator. It was until I just hit clear. Let's see if I can get it back. There it is. So I'm going to type that times tan 30. That gives me 6.298, so about 6.3. So x is about 6.3. So if I go back up here, that means the entire base of the big triangle is 27 times, sorry, not times, plus 6.3. So altogether, that would be 33.3. And we already said that the height here was 10.909. So I'm going to do 1/2 base times height. And that's 1/2 33.3 times 10.909. And that gives me, I really don't have to be as careful to keep using the same number as I was doing last time. I was really just kind of showing you how to do that. Because sometimes it'll give you a much more accurate number, especially if you're having to do a lot of stuff along the way, a multi-step problem, basically. So this gives me, and it's really approximately, 181.6. So that's what I get for my area. Let me go check the key. But this is actually with a CUDA worksheet, and with that CUDA worksheet it said 181.5. They probably actually were just not as careful. Maybe they rounded to 10.9 earlier. Same goes here. I think they got 36.5. I would take it either way. It's very close, and more importantly, hopefully you've shown your work so that it's clear to me or whoever your teacher is that you did it the right way. All right, and that is that.